Alright, hi everyone, we are continuing with our data structures and algorithms series. So far, we have learned how to calculate time complexity and space complexity and how to represent them using BigO notations. From now on, we will see some common problem solving patterns that will help us in solving questions with better performance. Our first pattern is frequency counters. As its name suggests, this pattern will help us in solving questions that involves counting and comparing occurrences of elements. For example, there is a string called hello. Now, if we asked, find out how many elements are being repeated in this string, then we have to count each character one by one. And then we will be able to find out that L is being repeated here, right? This pattern is helpful when we have to compare two arrays or strings. Also helpful when we need to check duplicates or missing elements. This pattern can help us in avoiding O of n square time complexity with arrays and strings. Basically, we can avoid creating nested loops. We will be able to understand it in much better way when we will see some example code. For that, let's look at an example here. We have a question: given two strings, write a function to determine if the second string is an anagram of the first. To understand it, let's see what exactly anagram is. Anagram is a word or phrase formed by rearranging the letters of another word or phrase. For example, AB can be formed from BA by rearranging the letters. Another example is listen. We can rearrange these letters and make silent out of it. Alright, now let's try to solve this question with two approaches. First will be a naive approach, like how a naive coder will try to solve it, and then how we can solve it using the frequency counters pattern. For that, let's move on to code sandbox. Alright, so I have a function here is anagram that takes string 1 and string 2. Now we have to find out if string 2 is an anagram of string 1 or not by using a naive approach. Alright, so as a naive, what I will do is I will just try to check if string 1 dot length is not equal to string 2 dot length, and then I will just simply return false, because if length doesn't match, then it cannot be an anagram, right? Because they have to have same number of elements, right? My next step will be to start a for loop and iterate over string 1, right? And then start another for loop that will iterate over string 2 so that we can match if string 1 element is same as string 2 element, right? Once we find out that string 1 element is same as string 2 element, then we will like to remove that element from string 2 so that we do not match it again in our second iteration, right? Once we find it, we will like to store it in our variable that we have found something. For that, let's create a variable here. Let found equals to false, and here we will make found as true, right? Once we found true, we can break and move on to our next iteration. And if we are not able to match our element in string 1 with string 2, in that case we can here simply mark if found. If not found, then return false, meaning string 2 is not anagram of string 1 here. because element doesn't match. And in the end, let's just simply return true, meaning that string 2 is an anagram of string 1. Alright, now let's try to run this and see the output. For that, I will open the console. You can see we are already getting true here because AB, if we rearrange this, then we can get BA as well. Now let's try to change it to something else, maybe hello. See, it says false because BA is not an anagram of string 1. Why? Because you cannot create hello from BA by rearranging the letters. Now if I change it to OLLEH, it says true because we can rearrange this word and then we can form our hello word, right? But this solution is a naive approach. Why? Because if you see, the time complexity of this function is O of n square. Why? Because we are having a for loop here and then we are having a nested for loop here. This for loop will run for n number of times because it depends on the length of our string 1, which can be anything. And every time it runs, it will trigger this for loop as well, which will again run for n number of times because it depends on the length of string 2, right? Which will make the total number of operations as n cross n, which will result in n square. That's why the time complexity is O of n square, which is very bad. Now let's see a better approach of it by using our frequency counter pattern, right? For now, let's close this preview tab and let's remove this code as well. I will keep this condition here because this one is still helpful. Now first thing we need to do is count the frequency of all the characters in string 1. Let's add a comment. Count frequencies of all characters in string 1. Alright, for that I will take an object string1 object, now let's iterate over all the characters in string 1 and try to add them in our object by calculating their frequencies as our value. For that I will just type string1 object. We need to keep character as our key and then counts is frequency, right? We need to make sure that every time if a character is repeating, we will increase this counter. For that we need to write logic something like string1 object get the current value and then do a +1. If that value doesn't exist, then count it as 0, right? If we use this hello as our example, it will look like something this: H1, E1, LS2 and OS1. Alright, so we have created our frequency object. Now we need to check if frequency of string1 chars is same in string 2 or not, right? For that we will need to iterate over string 2 and then try to check if string 1 object has this character or not, right? If this character is not present, we can simply return false. if it is present, then we can reduce the count by 1, right? So the conditions are, if character is not present, then simply return false, which means string 2 is not an anagram of string 1 because the characters doesn't match. But if it is present, then we will just reduce the count of our frequency by 1, which means with every iteration this count will change, and every time when a character is present this will be reduced by 1. By the end it will look something like this. If this happens, means characters are same and can be counted as anagram. Then we will return true, right? Now remember, we are not using nested loops here, we are using two different loops, which makes the time complexity as O of n plus n, right? Which can be simplified to O of n. That's it. Now let's check the output. For that I will open the preview tab and then open my console. Now you can see we are getting true as our output, which means string 2 is an anagram of string 1. We can test it further by using different words like still true, and now it says false, which means string 2 is not an anagram of string 1. Alright, that's all for this video. We just saw how we can reduce our time complexity from O of n square to O of n using the frequency counter pattern. Thanks for watching.